Yes, sir.
अच्छा नहीं इब्रार वो समझ आया था कि I told you कि you ये तो clear है ना, it's going to be Ag Br minus 1 or H2, one of the three that would lose electrons, right?
Yeah, exactly.
अच्छा, so how do you figure that out? वो ये था ना कि who likes to lose electrons? The one that has the lower E naught.
Highest lower, yeah.
ठीक है, so once you write down all the reactions के मतलब आप सारी equations ढूंढोगे and you'll try to figure out all the reactions where they're losing electrons, right? So for example, I found two equations for water where it's losing electrons, and you're going to look for the equation in the backward direction. Okay, for example, over here you would have Br minus 1 somewhere. So it's basically Br minus 1 that is losing electrons, right? So you found one equation for that. So इसी तरह you'll find that is 1.07 volts. We had silver as well, so we have an equation for silver losing electrons as well. Like if I rub this off, so remember the electrode was made out of silver, so I've got an equation where silver is losing electrons as well, and that's 0.80 volts, and I'm going to add that equation as well. So at the moment I've added the Br minus 1 equation, and just give me 1 second for the board. And similarly, I'm going to add just 1 minute. Okay. So similarly, I'm going to add the silver equation as well, where silver is losing electrons. And it's forming silver plus 1, and it loses 1 electron, and it has a potential of, I think it was 0.80 volts. So out of the four, which one has the lowest E naught? Remember, the one that loses or really likes to lose electrons is the one that is going to have the lowest E naught. And that in this case is the silver. So what that means is that out of these three substances, it's the silver electrode over here that is the one that has the greatest tendency to actually lose electrons. So what would be happening is that all this silver electrode over here, it's going to be dissolving. This is going to be dissolving, and it would be turning into silver plus 1 ions, because it has the greatest tendency to actually lose electrons and form silver ions. ठीक है, is this clear, Ibrar, Zahir, Nadine?
Yes,
sir.
So, and what about the other side? Who gains electrons? We just had two equations. I had no equation for silver gaining electrons. I couldn't find one. I found one equation where silver plus 1 ions were gaining electrons. So I was looking at the equation in the forward direction, and I had an equation for water gaining electrons. So who gains electrons? The one that has the highest E naught. And the highest E naught in this case is silver again. So what that basically means is, I mean, you did this in O levels as well. What that basically means is that silver ions are getting dissolved over here, and on the other side, the same silver ions, they travel to the other side, they get attracted to the negative cathode, and they gain electrons to form silver back again. So the anode is going to dissolve. So the overall effect would be that the anode dissolves, and silver deposit is going to be formed at the cathode. So silver deposit is formed at cathode. Okay, is this clear? Formed at cathode. Is this clear? Yes or no?
Yes, sir.
yes, sir.
Okay, so just remember this every time you have to do this. Now, the only thing I've added over here is that if you have a metal as an electrode, you've got two types of electrodes. Like in O levels, you had inert electrodes. I mean, inert electrodes are platinum or carbon or graphite. For example, you won't find any equation for, if you look at the data booklet, you won't find any equation for platinum, because platinum doesn't like to do anything. It doesn't like to gain electrons, doesn't like to lose electrons. Like even if you look at P, there's no platinum over here. So that means platinum is kind of inert. It doesn't do anything. So platinum is an inert electrode, and the other one is carbon graphite electrode as well, because you wouldn't find equations where carbon is either gaining electrons or losing electrons. Maybe no equation in C. So remember, those two are inert electrodes. For the others, you can find equations. So that's about electrolysis. We'll do more of it in past paper questions. The very last thing that we have to cover now is so there's another thing about feasibility of reactions that they've added, but we're not going to talk about it yet at this point. It has something to do with Gibbs free energy, so we'll talk about that when we do entropy. The very last thing is calculations. It's calculations related to current, related to time, and related to moles. So you're going to get questions related to calculations. And there would be a couple of formulas that you're already familiar with. Nothing new. Some physics formula like Q is equal to IT. Remember, current is the amount of charge in coulombs per second. It's Q over T, so it's current into time. So that's amperes and seconds. Okay, hopefully everyone knows this. If you've studied physics, this will give values in coulombs. So if you know the current that is flowing for a particular amount of time, you would know what amount of charge is flowing through the circuit. Whether it's electrolysis or whether it's electrochemical cell, a current is flowing through the wires. So that's the first formula. The second one that you have to know is, which you probably know as well, that one electron has a charge of 1.6 into 10⁻⁻19 coulombs. So you already know this, that one electron has this much charge. So what would be the charge on 1 mole of electrons? So if I have 1 mole of electrons, then the amount of charge would be, in 1 mole, you have these many electrons, 6.02 times, you have a huge number of electrons, 10⁻23 electrons. And each electron has a charge of 1.6 times 10⁻⁻19 coulombs. And this, if you calculate this on your calculator, this would come out to be 96,500 coulombs. Although these are approximate values, like all of these are rounded values. Like for example, the charge on an electron is not exactly 1.6. It's like, if I just Google the charge on an electron, it's not exactly 1.6, it's 1.60217. So it's got lots of numbers next to it. Similarly, the Faraday, I just wanted to see the exact value. It's not exactly 96,500, it's actually 96,485.3. So remember, these are rounded values. So for you, what you have to remember is 96,500 coulomb. This value over here is known as the Faraday constant. So it's the charge on 1 mole of electrons. And that's your Faraday constant. So 2 formulas. That's it. Q is equal to IT, that's the total charge that's flowing through the circuit. 1 electron, the charge is 1.6 times 10⁻⁻19 coulombs. But since you always measure quantity in terms of moles, 1 mole of electron is going to have this much charge, which is 96,500 coulomb, which is known as the Faraday constant. And you can write this, what we just did, this ratio can be written as F is equal to LE. What does F is equal to LE mean? F is obviously the Faraday constant. And L over here is the Avogadro's constant. And E over here is the charge on one electron. It's 1.6 times 10 per minus 19 coulombs. Right? Is this clear to everyone? Zaib, Zoha, Minahe, Librar.
Yes, sir.
So I mean, this formula usually is probably never used that often. All you have to, I mean, mainly you have to remember this this Faraday thing. Mainly you got to remember this Faraday constant. That it's the charge on 1 mole of electrons. So 2 new formulas. Remember that. I mean, this formula is basically kind of irrelevant. Don't take this formula very seriously. Just remember Faraday constant. Remember Q is equal to IT. So what type of question would you get on this? So we're going to do a sample question, and it would involve moles as well. So the question is, now the question is that let's say electrolysis of copper sulfate. So electrolysis of CuSO4 is performed for 1 hour. And during that electrolysis, 10 amperes of current was used. Okay, let's make it 1.5 hours. And he's saying calculate the mass of copper that's going to be deposited. So you're going to get simple questions, not very complicated. Mass of copper that's going to be deposited. Now we just did the electrolysis of copper sulfate earlier, and in copper sulfate electrolysis, the copper ions gain 2 electrons to form copper metal. So that is how copper gets deposited. We have the electrolysis over here, right? In somewhere over here, somewhere. I mean, you can notice that it's copper 2 plus that's gaining 2 electrons to form copper. So we have that information with us. So this all is given, and you're supposed to calculate the mass of the copper that's going to be deposited. Now, one thing that I can find in this is, what information do I have? I have the time that it's 1.5 hours and a current of 10 amperes was used. Based on that, I can find the total charge that passes through the circuit. So Q can be found. Q is equal to IT, so it's going to be current is 10 amperes. And it's being done for 1.5 hours. So that's 90 minutes, and every minute has 60 seconds. So it's 10 amperes into these many seconds. So 10 amperes into 90 into 60 seconds. Now, can anyone perform the calculation? Tell me what Q is. What is the total charge that's passing through the circuit?
450.
450, 4500. It's going to be a lot more than 450. What's that? कितना आ रहा है?
54,000.
ठीक है, so it's 54,000. ठीक है, that's kind of close enough. But you can double check 54,000 coulombs, right? So that's the amount of charge that's flowing through the circuit. So what can I do with that? What I can do with that is I can convert that into moles. Why? Because I know that 96,500 coulombs is 96,500. So I know that 96,500 coulombs charge is equal to 1 mole of electrons. So if the circuit, there is 54,000 coulombs that's passing through the circuit. So how many moles of electrons are actually traveling through the circuit? So I can find the moles, I can do crisscross, and I can find the moles, find the unknown quantity, and it's going to come out to be what would X be? X would be 54,000 divided by 96,500. So what are we getting? How many moles of electrons? What are we getting?
Zero 0.56.
No, it can't be 0.56. What's going on? Where are your calculators? Just a second. Remember, 54,000 divided by 96,500. Let me just check. 54,000 divided by, and that gives me 54,000. This is 96,000. I thought it was 9,600. Zeb, you're right. It's 0.56. It's going to turn to 0.56. So 0.56 moles of electrons are traveling through the circuit in this amount of time. So this is what we have done so far, that we've figured out the moles of electrons that are going through the circuit. So we did Q is equal to IT, we figured out the charge, and using Faraday constant, we were able to figure out the moles of electrons. So what do I do with that moles of electrons? I know the equation for copper getting deposited. It's this equation. So I have the equation. I'm just going to take the equation. I know the moles of electrons that are passing through the circuit. So the moles of electrons are already given. That's 0.56 moles. So according to the ratio, the amount of copper is going to be half of that. So what is half of that? Half of this is going to come out to be what? I mean, divide this by 2, I think. So that gives me 0.28. So that gives me 0.28 moles. And now I can find the mass. What is mass? Mass is moles divided by MR. So it's going to be 0.28 divided by MR. Not sure. Copper is probably 63.5, but you can check the data booklet. And if you use that, you multiply it by 63.5. And we're going to get 17.8 up to 3 significant figures. It's going to be 17.8 grams. So that's your complete question. So remember that Faraday constant, I mean, the purpose of the Faraday constant is to switch from moles to charge. I mean, that's the purpose. Like if you know what the Faraday constant is, then you can switch from moles to charge. And you can figure out the charge using Q is equal to IT. And you can convert that to moles. 1 mole of electron has a charge of this. So you can use Faraday constant to use ratios, which we did over here. We found the charge first, then we converted the 54,000 coulombs into moles of electrons, and that came out to be this many moles. Once you knew the moles of electrons in the equation, you can use ratios to figure out the moles of copper in this case. And you found that, and you were able to find the mass of copper. So is this question clear?
Yes, sir.
Okay, that's pretty much that's about it in the chapter. So we'll do past paper questions now, and we'll start now. We'll probably attempt just one past paper questions at the moment. So just remember Faraday constant in the last part. Now, where's the, just a second. Okay, let me just do one question which would be very similar to this one. Maybe the older past papers. So let's see if we can find some Q is equal to ID questions. That means no, not this one. Just hold on 1 second. Okay, anyway, so for example, let's just do this quickly. B part 1. He's saying that state the relationship between Faraday constant. We just said that it's F is equal to LE. Now he's saying that use the value and calculate the Avogadro constant. Remember, L is the Avogadro constant. He gave us the Faraday constant and he's saying that it's 9.60 into 10 to the power 4. So it's L into E, and he gave us the charge on the electron as well. So that's 1.6 times 10 power minus 19. So all you got to do is you have to find L, that's it. So you can pretty much do that on your own. Some other slightly more difficult questions related to this. Yep, this one. So this one is, he's saying there's a current of 0.5 ampere. It's the electrolysis of copper. And calculate the time. The time is missing. He wants us to calculate the time. And he's given us that 0.5 grams of the copper is getting deposited. So the equation for copper getting deposited, it's a copper sulfate electrolysis. I mean, you've got complete the following diagram to show how electroplating happens. So the electrolyte is going to be copper sulfate. Only then would copper get deposited, and it's going to be aqueous. So, and there's a DC source and so on. So copper 2 plus 2 electrons, it forms copper. Now, the mass of copper is given. So what I can do is I can find the moles of copper, and it's going to be 0.5 divided by 63.5. Mass divided by MR. So mass is 0.5. The MR is 63.5. And we calculate this and it comes out to be 0.0787 moles. So I found the moles of copper, which is 0.0787 moles. We found that. The moles of the electrons are going to be double the amount. So let's find the moles of the electrons. It's going to be double the amount. So I'm going to multiply that by 2. And I get 0.0157. So I found the moles of electrons, 0.0157 moles. What can I do with that? I can use the Faraday constant. I know that 1 mole of electrons, they have a charge of 96,500 coulombs. So if I have 0.0157 moles of electrons, then the charge would be X. You can cross multiply.
So how did you calculate your mole of electrons?
Ye wale. See, we found the mass of copper, right?
Gee.
I mean, the mass of copper was given, so I found the moles of copper. And it's 1:2. So the moles of the electrons are going to be double the amount. 1 copper gets deposited by 2 electrons.
Yeah.
And once I have the moles of electrons, I can use the Faraday constant and turn it into charge. So 96,500 into 0.0157. So this is going to be multiplied by 96,500, and that gives me 1519.7. So it's 1519.7 coulombs. Now I've got coulombs now. What do I do with that now? Remember, he was looking for time. That's the question. He wants to know time. So the last part is you can use Q is equal to IT now. That's the last thing. So time would be Q over I. So time would be, what is Q? It's 1519.7. What is the current? He gave us the current 0.5 amperes. I mean, the current was already stated over here. So this last thing needs to be divided by 0.5. So we're just going to divide that by 0.5, and that gives me 3039 dot. So up to 3 significant figures is 33. So it's basically 3,040 seconds. So is this clear? In this question, he wanted to know time. He gave me the moles of copper, and I found the moles of electrons. When I found the moles of electrons, using Faraday constant, I was able to find out the charge on those electrons. Once I have charge, Q is equal to IT, so I can find out the time. So is this question clear?
Yes, sir.
So next class, we'll be just doing past papers, related to electrolysis, electrochemistry. So we'll continue this in the next class then. TK.
Allah Hafiz.
Okay, everyone, take care. Allah Hafiz.
Thank you, sir. Allah Hafiz.
Allah Hafiz.